Hello all, a very warm welcome. Myself Adarsh, close to 19 plus years of IT industry experience, and I lead the DevSecOps and the SRE service line at Infosys. Of late, I've been working on platform engineering, which is why I wanted to present the topic platform engineering, the glue that binds it all together. Now, I do not promise a lot of watershed moments, but I'm sure this will infuse some new ways of thinking and add to the overall intellectual capital on platform engineering. My LinkedIn profile, as you can see, is mentioned below, and please feel free to reach out. So let's move ahead and see what I'm going to cover today. And as you can see from a table of contents, instead of the why, what, and how, I have done a what, why, and how. So, typically we call these as the three components of the golden circle. The reason to bring in a what first is because I believe there are certain blurry lines on platform engineering and a bit of an unfamiliarity with that topic. So let's establish the what first, followed by the why, which has certain subtopics under it, and then how to do platform engineering. And last but not the least, we will also cover an interesting dimension where the platform engineering is the key to success, or there is something else needed as well. So without much ado, let's talk about what is platform engineering. And as you can see from a definition perspective, it's a practice of building and operating a common platform, which can be used by our technology and product teams. Now you can see three different facets, which I've mentioned. So one of which is the self-service deployments for infra and applications. So essentially, this will help in easing out the operating of our apps in production. And in turn, this will bring down the time to market and the complexity. We talk about the reusable tools and the self-service capabilities. And again, this, augmented with your automated infrastructure operations will help in improving the developer experience and productivity and bring down the overall development time. And the third facet is standardizing the tools, components, and the automated processes. And this will ensure a consistent deployment across the platform, which will bring in more reliability to what sits in production and also reduce the manual effort. Now, one important factor here to highlight is that while platform engineering is helping in the developer experience improvement, this is also a vehicle for easing out the cloud native journey. So if you take a look at the elastic cloud infrastructure, whether we talk about configuration, we talk about service meshes, the networking, and the security, we can bring in as much as automation as possible. Now that we have looked at the what side of things, let's try and unravel what the components of platform engineering are. And as you can see on screen, the first factor, which is the infrastructure. And there we have infrastructure as a code, which means that all the code that we write from an infrastructure perspective is version controlled. We talk about containerization, which means that whether it is our configuration or our binary files or our libraries, all of that are part of the containers. And then, of course, the cloud. The second dimension here is the continuous improvement, which is basically continuous integration, continuous delivery, continuous testing, and continuous monitoring area. And lastly, we have the security, which I'm going to cover in a bit more detail as we move along. You can see the horizontal line, which is the engineering practices. And this is a horizontal layer because the idea is that we build quality software, which will have enough of code readability. It will be a clean code, will follow practices like test-driven development, etc. In fact, I remember that when we were setting up a platform for one of the large telcos in Australia, this platform was the CI/CD platform, which catered to 200 plus feature teams. We applied the acronym called SOLID, which is the principles that is used in the object-oriented world, SOLID. And one of those principles, the O, stands for open for extension, closed for modification. We had a similar concept in our platform as well. So let's assume if you were a feature team and you wanted to bring in, let's say, new linting rules, you could do so and easily extend that. But from a core platform perspective, you'll not be able to modify anything. So that is how we utilized, the open closed principle. The last but not the least, you can the layer that we have is the metrics, and that is because if you can't measure it, you can't improve it. Now, here is an interesting question. Who are the set of people who understand all of this above? And this tribe is called as the platform engineers. Let's take a look at some of the popular tool set that the platform engineers use today. And this may not be all comprehensive, but I'm just trying to give a glimpse of what actually looks good today from a tooling perspective. Of course, there are many other tools. But more importantly, I want to bring in a narration from, or an experiential share from one of our clients. So we had one of the largest platforms that we created on top of Azure for one of our clients based in Europe. And there it was a typical hub and a spoke model. So the platform engineering team would serve as the hub. And on Azure, they will continue to roll out the services, which would be around your, let's say, consumption patterns. It will be around your infra provisioning. It would be around your spoke provisioning. And typically, the spokes will be the feature teams who will continue to consume the services. So that is how we established the platform engineering using a hub and a spoke model for one of our clients. Now that I think we have firmly established the what, it's time for us to move to why platform engineering. And as you can see, the first point, which is innovation at the core. So we are looking at innovation in our deployment and the operation of our applications. And this helps in two ways. One, it will help in improving the engineering productivity and also reduce the overall toil of software development. The second aspect is the focus on the user. So in our case, the end user here is a developer. So, we bring in a lot of the self-service capability and automated infrastructure. So now, like we discussed earlier, it will add to the overall developer experience and bring in more productivity and reduce the overall development time. Given that there is a full-fledged automation of environments. The last aspect is the one team, one platform. And what it means is that we bring in, standardized tools, we bring in the components and processes to ensure that there is consistent deployment of the applications. And this will add more reliability to the overall process and how we manage the apps in production. Now, there are some other terms that you see on screen, right? So for example, reduction of the toil in the software development, improving the engineering productivity, ensuring consistency and building more confidence, and likewise. And it can also resonate in your mind that, well, you've heard some of these terms in SRE world, in the DevOps world. So I think it's time to unravel the difference between the platform engineering, SRE, and DevOps. So let's move ahead. Yeah, if I have to put a kind of a one-liner differentiation, I would say that platform engineering actually works to provide the rapid infrastructure for your application teams. Whereas when you talk about the SREs, they will bring in more reliability to the system and your services in production. DevOps will utilize the tools to streamline your deployment and then bring in the visualization. So the platform engineering will work on these tools and these processes and make sure that as much as reusability they can bring into the aspects. So to kind of summarize it, I would say that, let's take a look at the focus and the key responsibilities, and then we'll talk about the metrics and the benefits. So if I take platform engineering as an example, so the important construct here is that we are looking at the designing, constructing, and managing the platform, implementing automation and self-service. When you talk about DevOps, we are looking at bridging the gaps between the dev and the ops to ensure that we have a smooth deployment and then automating the software delivery process. Whereas when we talk about the SRE, we are looking at monitoring service performance, reliability, scalability, and automation to reduce the toil. There is another important dimension here, which is managing the incident response. Now, from a metrics perspective, you can see some of these metrics that we put, but like I mentioned earlier as well, these metrics may not be cast in stone. So every organization probably may have their own route as long as it helps them. So from a platform engineering perspective, what is important is the productivity and efficiency gains that we get. So we may have to look at things like, for example, cost of cloud resources. We may have to look at the infra and licenses. And because the platform engineering is aimed at improving this developer experience, When we talk about the productivity improvement, that is where time to market becomes very important. Um, Even the developer productivity. So if you have, let's say, a lot of reusable components which you present as part of a catalog and the developer chooses it, that helps in enhancing the overall developer productivity as well. And then, of course, there is a key metric across the platform availability. From a DevOps lens, rather than just mentioning deployment frequency, which is written there, I think deployment cadence and success, that becomes equally important. And then, of course, your mean time to recover. When we talk about the SRE, we are looking more at the SLOs, SLAs, and the error budgets. Now, of course, from a benefit perspective, we've already discussed how some of these metrics and some of the ways of working will help. So I'll move on. There is an interesting dimension which I did not cover so far, which is ingraining the security into the platform engineering setup, as this will give further insights to our developers on what has been deployed. Is it secure enough or not? So let's cover that. Now, from a security lens, I think it's important to understand how the attack vector has changed in recent times. If you take a look at the world today, the hackers are a lot more organized. If you take a look at some of the latest statistics, there is an average 20% increase in CVE year on year. And the 50% of the exploits are published within the 30 days of the CVEs. When I say CVEs, the common vulnerabilities and exposures. So we are not able to prevent this in the first place. We are more reactive than proactive or preventive. And for that, we need to shift left the quality and security. So which is why you see those three dimensions on the screen: the microservice security, the container security, and the CI/CD pipeline security. They become very relevant. Let's take each one of them. So if I take microservice security, for example, using the basic principles like HTTPS, making sure that we use OAuth2 and OpenID Connect. We should use, say, for example, tools like Azure Key Vault to protect and encrypt our secrets. When you look at the containers, we are looking at container runtime, we are looking at application isolation, and protecting the container apps and the infrastructure. When we talk about the CI/CD pipeline security, we are looking at bringing in the quality and the security gates so that we do not allow spurious code to move into production. Now, what we'll do is we'll move ahead and we will talk about the trends. From a leadership perspective, it is important to keep an eye not only on the bottom line, but also on what is trending and what does the future beckon for us. So rather than just covering the future trends, I think first the emphasis should be on what is happening in the current world of platform engineering and what is the current state. So there is a massive interest in adoption to accelerate the innovation via platform engineering. If you take a look at the latest Puppet report of 2023, the topmost reason to set up platform engineering is to speed up the software delivery. From a future trends perspective, I think the first one on screen that you see, which is the emerging technologies and the use of serverless, that becomes very important, especially when we are talking about the multiple advantages that serverless will bring. There is an increased focus of, let's say, an environmental impact by reducing the energy, and this is where serverless comes very handy. Then we look at how AI/ML can improve the SDLC. And I wanted to give an example of how we have built a release predictability model within our platform. So it takes a look at the number of dimensions across your plan, build, and the run construct. And then it brings in a release predictability score saying that whether your release that is going to happen, let's say in 15 days or 20 days from now, it'll be successful or not. So a lot of AI/ML influence now on the SDLC. And the last two factors, of course, kind of very relevant, because if we are looking at a large-scale digital transformation adoption, then it will fuel the platform engineering anyways. I'll move ahead. So now that we have established the why, the time to look at the how, because it is said that, the stronger the why, then the more easier the how becomes. So let's look at how we do platform engineering. And for that, I'll bring in a live example. So for one of our Singapore-based organizations, we wanted to ease the lives of the developers on the infrastructure. So the platform engineering team created the platform so that if you need any infrastructure on top of AWS, you can raise a request via ServiceNow and post the approval of that request. The Terraform Enterprise API was implemented. So if your request is approved, then uh, there is a pull request, and the HCL, which is the HashiCorp configuration language, that those scripts will be pulled up from the Bitbucket, and they will implement the service request. So once the API call gets received, then Terraform gets initialized with the respective workspace. Then you have the Terraform plan, which is applied. And as you can see, we have imposed the Sentinel policies. For those of you who are not aware on the Sentinel policies, basically if you want to implement the governance policies as a code, that is where you utilize it from a Terraform perspective. Then Terraform will apply the changes or create the new infrastructure on AWS, which you can see here. And once it does, then all of the changes, the state files that we talked about, they are all stored in the S3 bucket. So to summarize it all, it has become very easy for the developers as part of a decentralized control to maintain and manage their own infrastructure. And that way is now they can focus more on the business features. Now, a very important step here is, and we talked about this earlier as well, are the metrics. So if you take a look, if we are looking at metrics, and these are some, if we bring in some poor metrics, then they add to a lot of inertia, and there are high switching costs. So it is always very important that given that we bring in the right set of metric, and for that, I think it is important that we understand why we have built the platform. So from a platform perspective, we built it because we want more speed. So our quality and frequency of releases goes high. And we also want to bring in stability. So the metrics across productivity, speed, and stability become kind of a North Star for us. And as you can see on screen, some of these metrics, like, for example, lead time and deployment frequency, which are your metrics across your speed. So lead time, for example, is from the time you check in your code until the time that same code hits production. We want to bring it down as much as possible. And from a deployment frequency perspective, how frequently are we deploying to production, and what is our success rate there? From a stability perspective, the change fail rate, so the number of times the deployment happens, how many times it actually fails or results in a degraded service. And then finally, the mean time to recover. So these are some of the important metrics. Now, if you observe, these are also the DORA metrics, which have become very popular and kind of de facto for a lot of engineering organization or the engineering side of things. So the idea here is, if I have to crystallize this whole topic, the platform has to be treated like an internal product. And the success metrics should be based on the top goals of what the organization has set for the platform to do. And this should be the same like you treat your customers, but only from an engineering lens. I wanted to bring in a few examples just to illustrate a bit more on metrics, and like I said, how poor metrics can result in high inertia and high switching costs. So if you set up, let's say, a dashboard which has numerous metrics, and you can't derive the true value out of it, it kind of becomes very difficult. Whereas if you take a look at second case, so this is a very neat set of metric that actually helps in decision making for a product owner. So there is one API which is broken down into 4 distinct microservices. And for each one of them, we calculate where we stand in terms of our error budget. And if all of them are green, then the release recommendation is actually to go ahead for the product owner. But let's assume if one of them was red, then in that case, the product owner can take a conscious call. So he or she can take a risk of going ahead with the release, or they can actually move one of these services, which is red, out and then move the other 3 in. So when you have this kind of an observability on your screen, it can help you in making some good rational decisions. Now I'll come to a very interesting topic, which is platform engineering a magic wand that can drastically bring down your time to market, that can add to the developer's happiness and help in breaking down the team silos? is just setting up of the platform, will it do the trick? And the answer is no. There is a very, very important change management aspect of things, which includes your training, collaboration, and that will actually augment what we built as part of the platform. So, like you can see on screen, for one of our clients, what we did is we brought in this education and empowerment exercise for the developers and the product teams so that they could reap the true benefits of the platform. And as you can see, there are training sessions that are happening right from the leadership all the way till the team members on various distinct topics, so that is where they will understand a bit more on the platform and not only appreciate the platform, but actually hop onto the platform a lot faster. One important area that you see, which I have highlighted in bold, is the area across security. So let's cover that in a bit more detail. Now, if you take a look, the platform has been built and the platform has various checks and balances on security as well. So you may have tools like your SAST scanning tools, which is static application security testing. You may have your third-party library scanning tools. You may have your container scanning tools, and they may all be embedded as part of your overall, let's say, CI/CD platform with enough gated mechanism. But it is equally important to build the security ethos within your feature teams. And for that, for one of our clients, for example, we created a whole program across security, and we created these security torch bearers within the feature teams. So you would nominate, let's say, your team members to a security program. They will get certified gold, silver, bronze levels, which are kind of different levels of training. We brought in game mechanics as well so that we keep the people engaged and motivated. And that is where we helped in uplifting the overall security capability. This is very significant because if you take a look at the data as well, the NIST data says that if you have to fix a security bug in production, it will cost you some $7,600. Whereas if this was caught early in the life cycle, say in a QA environment, it will cost you around some $960. Whereas if this was in a dev environment, it will cost you around $70 to $80. So our idea is that we shift left quality and security as much as we can. Now with that, I come to the end of our presentation. And as part of the conclusion, I will say that the platform engineering will never be a straight line. This is a journey. And like any journey, there will be a series of advances and retreats. And the team should work on each other's strengths and the capabilities to produce the best outcome. Thanks for being a patient listener. Have a great day. Thank you.